Hi everyone. In the last lesson we were looking at resisted motion, and we saw that resistance is usually in proportion to the velocity of an object. So we're going to build upon that concept and have a look at terminal velocity. So terminal velocity basically means as you keep going faster and faster, as your velocity increases, so too will the air resistance. Your air resistance will get greater and greater as your velocity increases, and you'll reach a point where you can't increase the velocity anymore to overcome this increasing air resistance. And that's called the terminal velocity, the point where you can't actually increase the velocity anymore. And that's when your acceleration will become zero. So if someone was, for instance, to jump out of a plane, they would accelerate and continue to accelerate until they reach a certain point called the terminal velocity. And that's when the air resistance force, so if you draw a picture here, so something's thrown out of a plane, it will keep speeding up due to gravity, but the force opposing this will get stronger and stronger as it gets faster, and you'll reach a terminal velocity where the velocity is constant. It's no longer going faster and faster. The velocity is constant, and that point there is the terminal velocity. So algebraically, this is represented as the velocity as time approaches infinity, time gets very large, or as acceleration approaches zero. This is how we represent terminal velocity. So in the previous lesson, we did a resisted motion question, and we got a relationship V equals 1 on K G minus G e to the negative KT. And this was an expression for the velocity of an object that's dropped. So any arbitrary object that's dropped, this is the relationship between the velocity and time. So if we wanted to calculate the terminal velocity of this, we would look at what happens as t gets extremely large. What happens to our velocity then? And so if we have a look at that, as t gets extremely large, this will become an extremely large negative number. And due to the index law, x to the negative 1 equals 1 on x, for instance. Well, that doesn't have to be 1. It could be anything. You could make that k 1 on like that. That's fine. Due to that index law, that means this whole thing will approach 0, because as x approaches infinity, then 1 on x will approach 0. So this whole thing will approach 0 as t gets extremely large. So that means this whole thing will approach 0, and that means all you are left with is v equals g over k. And keep in mind, g is a constant, it's the gravitational constant, and k is a constant. So as t gets extremely large, you're left with your velocity equals some constant. And this would be the terminal velocity, whatever that is there. It's going to depend on the value of k for your specific case. But this is how the terminal velocity would be represented. So yeah, that's a look at terminal velocity, and basically it comes about because as your velocity keeps increasing, so too will the air resistance, and you'll reach a point where you can't increase the velocity anymore because the air resistance is just getting too large to overcome.